Okay, so in this video I'm going to show you how to use our cell counter, which is the Viability Countess 2, located between the two cell culture hoods in the cell culture room. If the blue light's on, that means the instrument's on. The screen may be dark. You just hit the screen, it will look like this. If the instrument's ever totally off, there's an on-off button in the back. You could turn it on. And so what we're going to need is, well, I've already trypsinized some cells, and so that's what you need to start with. You need to start some cells that have been trypsinized in media. We'll take a microcentrifuge tube. The drawer below here has these little slides that basically will fit into the instrument to do the cell counting. And then we're going to need some trypan blue dye. The trypan blue, it gets taken up by cells that are dead, that have permeabilized membranes. And so we can use this to quantify the percentage of cells that are alive or dead in the trypsinized cell suspension. So, first things I'm going to do is I'm going to take the P20, and we need 10 microliters of the cell suspension. Again, if cells have been sitting around, they're going to settle, so you want to make sure you mix things up so you have a nice suspension of cells. Pipette up and down a few times, and then take 10 microliters. I'm going to put it into this microfuge tube. And then I'm going to take 10 microliters in equal volume of the trypan blue. And then just pipe up and down a few times to resuspend. And then what we're going to do is open the slide. There's two parts of this, so you can actually measure two samples labeled A and B. I'm not sure how visible it is. We're going to do the A first. Basically, I'm just going to take 10 microliters of that cell suspension, pipette it into, if you look there, there's a little bit of an opening there where you can pipette the liquid into there. And I'm going to take it over to the cell counter here and basically just stick it in the slot there. It'll catch, you'll hear it catch in there. What it's going to do next is autofocus, and so it's going to kind of, the camera in there's going to go up and down and focus on the cells. And once it's stopped and looks focused, you can just hit capture here. Okay, it gives you a bunch of information here. If you look at the image there, you can actually zoom in as well. There's little green circles around everything it identifies as an individual cell. And there are different settings you can use with this. So I have this temp setting to avoid things that are too small. This instrument can have problems sometimes quantifying debris that might be really tiny particles or something that's precipitated. And cells have a given volume of 10 to 15, 20 microns. And so sometimes you can have issues with it. When you actually hit graph here, it'll tell you the size distribution of all the cells. So I mentioned most cells are 10 to 20 micrometers, and that's what the distribution basically looks like. Also shown on the right of the screen is the information we need here. So it gives you the total concentration and then the percent of live cells. So I have 100% viable cells, which is maybe the first time I've ever gotten such a high number. Typically it's on the order of 95 to 100% live. And so we can record that information. So we're counting cells for a reason, to count them, maybe plate a certain number of cells. So I have 1.6 times 10 to the 6 cells per mil. So it's 1.2 million cells per milliliter, and 100% viability. Oftentimes I will measure every one twice, so I'm going to go back and then take another 10 microliters into the B slot here, and just like before, put it into the slot. Again, it'll autofocus. And once it stops and looks focused, you can further focus it. We don't need to do that today, and just hit capture. Okay, so now in the second reading, 1.06 times 10 to the 6 cells per mil, 98% viability. So again, there will be some variability in the results you get. That's why I like to measure it twice. Sometimes you'll have cases where the numbers are way off, and again, maybe the cells settle down when you pipetted something. And so if you ever get wildly different numbers, just try measuring again, make sure the cells are resuspended. And then we can, just to be sure you have accurate numbers. There is some range. It's not, these instruments are not perfect. Nothing's perfect in terms of measuring information or measuring different things, but we will use these numbers to calculate how many cells to plate. And again, I've got 3 more sets of cells to do that with, and I'm going to do that separately. But that's basically an easy overview how to use the cell counter.